Dear students, in this session, we will look at the evaluation and adjustment of errors in age and sex data. We have already seen what are the major errors which are taking place in the age and sex data, particularly in the context of India. So, it is important that we evaluate them and perhaps make adjustment in these errors, so that we would be able to derive accurate demographic indicators. The term evaluation is defined as a continuous process of examination or assessment of any process which forms the basis of a learning, updating and relearning of the process. So, naturally, the evaluation means we are reassessing the available information for better understanding. The evaluation of the errors in the age and sex data is one such method that works on the conceptual framework of continuous assessment of various types of discrepancies in age sex data in a census or a survey, comparing it with some standard age sex distribution, minimizing the errors at various levels and updating the procedure in a holistic manner. Any survey or census conducted in any parts of the world, however precise, is not free from errors. There are generally two types of errors in census and sampling referred. There are generally two types of errors in census and sample surveys, referred as sampling error and non-sampling error. What is a sampling error? A sampling error is an error that occurs when using samples to make inferences about the populations from which they are drawn. There are two kinds of sampling errors. It can be either random, which is known as random error, and sometimes it is a bias. A random error is a pattern of errors that tend to cancel one another, so that the overall result still accurate and reflect the true value. Every sample design will generate certain amount of random errors, which is expected. Bias, on the other hand, is more serious in nature, because the pattern of errors is loaded in one direction or another, and therefore do not balance each other out, as in the case of a random error. Therefore, producing a true distortion in the age and sex data is often happens because of the biasness in the survey or in the census. Let us look at the non-sampling errors. The non-sampling errors are those errors which are due to factors other than sampling. Non-sampling errors are further classified into specific errors, ascertainment errors and tabulation errors, among which ascertainment errors are accompanied by coverage error and content errors. These errors are intrinsic in most and every step, beginning with conceptualization of the topic and to its operationalization and till dissemination of the data. Since census is based on a complete enumeration of the population, that it is completely free from the sampling errors, but non-sampling errors are very much integral part of the census as well. Let us now see why an evaluation of errors in age and sex data is necessary. The error-less information on age and sex is very much needed for the computations of several statistics of fertility, mortality and migration in population sciences. The higher is the accuracy of the age-sex data, higher will be the reliability of the estimates which are derived in demography. The evaluation of the errors in age and sex data corresponds to both the separate errors in age data and sex data, and also the errors due to interaction among the age and sex. The first important error that arises in any census or survey is concerned with the quality of the information on the coverage of the sex data. Types of consistency checks available gives you some understanding of what is the extent of these errors in age and sex information. There are basically two types of consistency checks that are possible for the age-sex data. One is known as direct checks and second is known as indirect checks. The direct checks on the age and sex data involves post-enumeration surveys, where some samples of the households are revisited to ascertain the accuracy of the information on age and sex composition of the households once a census enumeration have been completed. Indirect checks, on the other hand, employs comparison of age and sex data using both internal and external consistency checks. Internal consistency checks refers to the assessment of the relationship of age-sex data within the same census, whereas external consistency check employs comparison of census or survey age-sex data with the age-sex information available from some past sources or from other data sources. There are some important consistency check mechanisms or assessments of errors in age and sex data as recommended and discussed by agencies like UN in the UN Manual 1955 and also US Bureau of Census in 1985. Some of the major aspects of the consistency checks reported in by these agencies are as follows. First, the consistency checks based on the information of one or single survey or census. It means that the checks will be done only using an information from one census. So, simple measures like rates, ratios are used to understand the quality of such data. The second, through matching the information on age-sex data with the information from some authentic sources available in a country. Any survey or census which was computed in a particular point in time will also compare its data with the existing expected to be good quality data from other sources. So, which will provide an understanding of whether the data collected from the census or the surveys for that particular point in time is accurate or inaccurate. Third, through the comparison of observed age-sex data with the theoretically established balancing equation or population projections or stable and quasi-stable population models. There are different types of population age sex distribution has been worked out through stable population and quasi stable population and through other equations, mathematical equations, which provide an information on what would be the likely structure of the age and sex population if the fertility and mortality follow a particular pattern. Therefore, it is possible that a comparison of the age and sex data with the data available from standard models or the stable and other quasi stable population models are used to compare to find out the extent of the errors which might have crept in the particular survey or census. Fourth, a direct comparison of the values with the information obtained from re-enumeration of the sample from the survey data. So, it is possible that a re-enumeration of some of the samples might provide some information on the quality of data captured through the survey or through the census. So, now let us come back to the evaluation of age sex data. The methods available to evaluate and find out the extent of errors in the age sex data. We will start with the first one, the consistency check based on the information on a single census or a survey data. The most intensive method of evaluation of errors in the age sex data are based on the availability of data as given as graphical analysis of age sex distribution, which is generally known as population pyramid or age sex pyramid. In the previous sessions, we have already learned how we can represent the age sex information through a population pyramid, which provide a good visual understanding of the age and sex situation in a particular geographical area. This is a very profound method of evaluation of changes in age and sex structure of a population within and between two or more time period. Thus, age and sex pyramid holds so many information of age structure and corresponding sex composition of the population, starting from the lowest age group 0 to 4 and to the highest age group. This is a vital tool available to understand and to measure the quality of the age sex data. Any discrepancies found between in the shape of the curve or any discrepancies found in the shape between the male and female can perhaps show that the data captured through the survey or census is not appropriate and accurate and needs corrections for the further use. The second method, as we have already pointed out, is the age reporting or heaping, which can be addressed or understood through certain methods which are available to compute the extent of heaping. It has been in the census and surveys. It has often been found in census and surveys that people generally misreport their ages or report it at certain preferential digits due to the bias associated with certain numbers. The important measures of the evaluation of the errors of the age sex data are given by age-sex ratios and age-sex accuracy indices such as Whipple's index, Myers index, even age-sex accuracy index. These methods of evaluation of age-sex data will be dealt in detail in subsequent sessions. Thirdly, we can also analyze the sex ratio of the population, which generally is considered as one of the important measures to evaluate the accuracy of age and sex data, and particularly the sex data. Sex ratio is defined as the number of male per 1000 females in a population and is generally referred as the masculinity ratio. So, the sex ratio is male population divided by the female population into 1000. Sex ratio above 1000, that is excess of males compared to the females, indicates an excess of females. It is widely used method to assess the consistency of age-sex structure data in a single point of time, as data available at multiple time points at single point in time, also even data available at the multiple point in time. Similarly, masculinity proportions are used to compare the sex distribution in the census and surveys. The masculinity proportions is simply the male population divided by the total population into 100. It simply means the proportion of males in the total population. As a result of 50 for masculinity proportion is standard of the balance between the sexes, and a values higher or lower than 50 indicates a deficit of the population of either sex. Also, the relation between sex ratio and the masculinity proportion is also given as masculinity proportion is equal to sex ratio divided by 1 plus sex ratio into 100. The third very important measure of sex composition is that excess of the male as a percentage of the total population is given as excess deficit of male is masculinity proportion minus 1 minus masculinity proportion. A negative value of the measure indicates excess of female, whereas a positive value indicates to the excess of males in the population. So, all these sex ratio and the masculinity proportion provides a good understanding of the quality of sex data in the population, because it is expected that the sex ratio or the masculinity proportions in a place will be in a very safe range of a particular value, depending on the cultural and social context of that country. If the census of the surveys gives a value beyond the expected value, it is possibly because of the errors that are crept in the sex data. The other second important method which can assess the quality of age-sex data is a consistency check based on the information on multiple census or the survey data. It is difficult to apprehend the quality of age-sex data through a single time point, because the errors in the age data in a census or a survey may have some inherent irregularities as well. The techniques involving information on age-sex from 2 census or 2 survey data points can A bridge can bridge this gap by analyzing and comparing the errors and the randomness through empirical techniques. There are several techniques to estimate and evaluate the age-sex information from 2 or more data points. One such possible technique is comparing census with other survey or sources of data. In this method, age and sex structure and population estimates from one source of the data is compared with the similar information from other data sources to match the quality of the data. This is very useful as it will provide information on the reliability of the data in comparison to the other sources which are perhaps better reliable or more reliable. A comparison based on inter-census cohort analysis or cohort survival is the second possible ways to compare two data available at 2 time points. In a population that is apparently close to migration, the population between the 2 successive censuses can be linked with the variations caused by births and deaths. For instance, the population of male or female between ages 5 to 9 in one census will be linked to the population 15 to 19 in the subsequent census a part of 10-year period. Such information, in case available, the population belongs to one age group X and the same population X plus N in the second census enumeration time can be compared. So, X at the earlier census can be compared with X plus N of the present census. The enumeration of time t is the time is denoted as t in such situation. So, t can be compared t plus n. So, the population belong to age group X or X plus A can be compared with X plus A plus n on the next census conducted at time t plus A. The cohort survival ratio is given by n, which is the population in a particular census, into X plus A, which is for a particular age group, into t plus a period divided by the n x for population at a particular age at point time t. It simply means that the population in the current census, the latest census, for instance in 2011 census of age 25 to 29 can be compared with the population in the last census in 2001 with the population t period, which is 15 to 19 years of age. The curve of cohort survival ratios obtained for different ages are used to assess the errors in the age data. If the life table survival pattern is available for the administrative units, then the ratio of cohort survival to that of the life table survival gives you an understanding of the changes in the age sex structure of the population, because the population in 2001 census 15 to 19 should be higher than the population in the current census of 2011 census 25 to 29, as all the persons who were alive in 15 to 19 in 2001 census would not have survived to the 2011 census period when they reached 25 to 29 age group. Similarly, we have other methods also for comparison, like cohort survival regression techniques. Normally, ordinary least square method of regression is used to derive the correlation factor to bring consistency among two census age distribution. Basically, it provides a correlation to the coverage error and provide a correlation factor for the population of two successive census. As we have already pointed out, the other method to evaluate the age and sex quality, data quality, is the post-enumeration surveys. The post-enumeration survey PES is a complete re-enumeration of the random sample obtained from the enumerated areas to match the records on age, sex obtained from the census recently conducted. The selected unit form some specified administrative area under the complete re-evaluation of the information on the age, sex characteristics. The post-enumeration surveys is very crucial for the census as it clarifies the presence of serious coverage and content errors in the census. Thus, various methods of adjustment for the age-sex data can be applied once errors are detected through census age-sex post-enumeration survey. Since PES or post-enumeration survey is an independent mechanism to re-evaluate the area, it requires appropriate sampling plan, the finance for good evaluation of the census data. Also, through PES, one can identify the erroneous procedures in the census and the large-scale surveys, and hence it can be rectified for the improved implementation of the future surveys and census. In India, the post-enumeration surveys are often carried out soon after the census in each decade. The post-enumeration surveys provide us a good understanding of the errors that creep in the census, the decadal census in the country. Although the post-enumeration surveys are an indication of the types of errors which can be corrected for the subsequent period, it has never been used to adjust the data quality for the Indian census, age and sex data of the Indian census. Finally, let us conclude on what we have learned in this chapter. The age-sex data is of very vital importance, and any errors that creep in the age-sex data can potentially give very wrong information on several demographic indicators and also can have vital deficit and can also have serious issues relating to policy and program implementation. Therefore, an evaluation and adjustment of such data is of very important. We have also looked at the types of errors that can creep in. There are direct problems, there are indirect issues, there are direct methods and indirect methods. All these measures gives you some basic idea about what are the major problems with the age-sex data available through census or through large-scale surveys. The adjustment in this data, if potentially carried out based on the evaluation procedure, can in fact provide much more accurate data than directly derived from the large-scale survey or census, which are expected to be erroneous due to various social, cultural and other factors which are existing in the country. Therefore, it is important that age-sex data are subject to scrutiny and evaluation and adjustment in a very proper way. There are methods available, some of them which we have already covered in this session. We will cover more on such methods in the subsequent session. Thank you.